Hi everybody, we are still in problem set 1.1 and we are in question 7, exercise 7. The question is, if we have two vectors, let's make them the blue vector and the red vector. Okay, so the blue vector would be 2 and 1, and the red vector would be 0 and 1. Okay, and we take linear combinations of these two vectors with C and D. Okay, C times this one plus D times the red one. C times the blue one plus D times the red one. And we take several C's. We have 1, 2, 3 options for C. And also for D, we have 1, 2, 3 options for D. Okay, so let's calculate what are the options. We have C times, I'm sorry, now we give real values. So the first C is 0, so we say 0 times the blue one, which is 2, 1, plus 0, which is the first option for D, 0 times the red one. The red vector is 0 and 1. And how much it gives us? It gives us 0 times 2, which is 0, plus 0 times 0, which is 0. So 0 plus 0, it's 0. 0 times 1 is 0, plus 0 times 1 is 0. 0 plus 0 is also 0. So the first vector we need to draw is 0, 0. Okay, so let's write it down. Or maybe let's calculate all of them and then draw. Okay, so the second option that we have is the blue vector this time times let's make first all the C's 0 and each time a different D, and after this we will change to the next C and also each time a different D, and then the last C and each time a different D. Okay, so we are still with 0 times the first vector, the C is still 0, plus this time 1 instead of D. Okay, and the red vector would be the same as it was, 0 and 1. Okay, so we write here 0 times 2, it's 0, plus 1 times 0, it's 0, so 0 plus 0, it's 0. 0 times 1, it's 0, plus 1 times 1, it's 1, so 0 plus 1 is 1. Okay, and let's see the last combination with the 0C. 0 when C equals 0, so it's 0 times the blue vector. The blue vector is all the vectors don't change in this question, they are staying all the same all the time. but the parameters now d equals, we tried with 0, we tried with 1, now we try with 2. Okay, so d equals 2. The red vector is the same as it was. We have 0 times 2 is 0, plus 2 times 0 is 0, so 0 plus 0, the first component is 0. 0 times 1 is 0, plus 2 times 1 is 2, so 0 plus 2 is 2. Okay, so now we move to another C. We tried C all the time 0 now, and we tried all the D's, all the possible D's, 0, 1, and 2. Now we will try C equals 1. Okay, so we have 1 equals the blue component, plus 0 equals the red component, equals something. I'm just preparing so it will be easier for us. 1 equals the blue component, plus 1 equals the red component, equals something. And lastly, 1 equals the blue component. It's not the last combination we will try, it's the last combination with C equals 0, with C equals 1. You remember? C equals 1, C equals 1, C equals 1, and D equals 0, D equals 1, D equals 2. Okay, so the blue vector remains the same all the time. It's 2, 1. So 2, 1, 2, 1, 2, 1. The red vector stays the same all the time. It's 0, 1. So it's 0, 1, 0, 1, 0, 1. And now we calculate. 1 times 2 is 2. Plus 0 times 0 is 0. So 2 plus 0, it's 2. 1 times 1, it's 1. Plus 0 times 1, it's 0. So 1 plus 0, it's 1. 1 times 2 is 2. Plus 1 times 0 is 0. So 2 plus 0 is 2. 1 times 1 is 1. Plus 1 times 1 is 1. So 1 plus 1, it's 2. 1 times 2, it's 2. Plus 2 times 0 is 0. So 2 plus 0, it's 2. 1 times 1. 1 times 1, it's 1. Plus 2 times 1, it's 2. So 1 plus 2, it's 3. Okay, now I don't have room for the next C. Now C should be 2 and 2 and 2. We will make it in a different page, in a new page. So it's problem 7, continued. And we have a C, which now is 2 times the blue vector, and 2 times the blue vector, and 2 times the blue vector, plus D, which is 0, and D, which is 1, and D, which is 2, and each time times the red vector, right? And equals each time a different result. This equals something, this equals another something, and this equals another something. Okay, let's see how much we get. This is the blue vector is all the time 2 and 1. Okay, so let's write it down. 2, 1, 2, 1, 2, 1. Okay, the red vector stays the same all the time, 0 and 1. So it's 0, 1, 0, 1, 0, 1. And we have 2 times 2, 4, plus 0 times 0, it's 0. So 4 plus 0, it's 4. 2 times 1 is 2, plus 0 times 1 it's 0, so it's 2 plus 0, it's 2. 2 times 2 it's 4, plus 1 times 0 it's 0, so it's 4. 2 times 1 it's 2, plus 1 times 1 it's 1, so it's 2 plus 1 it's 3. Okay. 2 times 2 it's 2. I'm sorry, 2 times 2 it's 4. Plus 2 times 0 is 0, so 4. 2 times 1 it's 2, plus 2 times 1 it's 2, so it's 2, plus 2, it's 4. Okay, so now we have all the 9 combinations. We have this one, this one, this one, this one, this one, this one, and this one, and this one, and this one. Now we need to draw them. The question asks us to draw them on the XY plane. So let's draw the XY plane. I'm not drawing it like this in the middle of the page. I'm drawing only the first quadrant because all the numbers that we have are 0 or more. So they are all positive. So I don't need to draw the negative quadrants. Normally there is a cross here, the X and the Y. And there is first quadrant, second quadrant, third quadrant, fourth quadrant. This time I only draw the first quadrant, which is positive X and positive Y. Okay? Because I want to make it bigger and easier. And all the numbers are positive, so I can do it. Positive or 0, but 0 is the origin of the axis. So this is the x-axis, and this is the y-axis. Okay, and we make it, let's say, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 22. Okay, so I'll make it each 7 squares. I will make a dot, 1 unit. So 1, 2, 3, 4, 5, 6, 7. This is 1, 2, 3, 4, 5, 6, 7. This is 2. 1, 2, 3, 4, 5, 6, 7. This is 3. 1, 2, 3, 4, 5, 6, 7. This is 4. Okay, and here I will make the same thing. 1, 2, 3, 4, 5, 6, 7, which is 1. 1, 2, 3, 4, 5, 6, 7, which is 2. 1, 2, 3, 4, 5, 6, 7, which is 3. 1, 2, 3, 4, 5, 6, 7, which is 4. Okay, and now we will draw all our 9 vectors. The first vector is 0, 0. We have not, but 1 second before I draw, I want to ask you, what do you think will happen? Because I will draw for you the blue vector and the red vector, and you will try to guess. Okay? So this is the blue vector. We will draw it in blue. So it's, do you see? It's 2 and 1. This is the first component. This is the second component. So the first component is 2. The first component is the x coordinate. The x grows positively in the from left to right. Okay, so in this direction. So the x-axis goes like this. So it will be 2 to the right, because 2 is positive. It's not minus 2, it's plus 2. Okay, and so we are going 1, 2. And the second component is the y coordinate. So the y-axis goes in upwards in the positive direction of the y-axis is upwards. So it's 1 unit upwards, okay? Because it's +1 and not -1. It's +1. So it's 2 to the right and 1 upwards. So 1, 2, this is the blue vector, and 1 upwards to here. Let's make an arrow. Okay, this is the blue arrow is the blue vector. 2, 1. The red arrow, which is the red vector, 0 in the x, so 0 to the right, so no going to the right at all, and 1 upwards, 1 in the y coordinate. Okay, so 1 step upwards. So not going to the sides, not to the right and not to the left, because it's 0 in the x coordinate, and in the y coordinate it's 1 step upwards because it's +1, not -1, +1. Okay, so this, we start from 0, we're not going left or right. And this is the red vector. Now what do you think will happen? We multiplied each time the vectors by something else. So one time by 0, one time by once by 1, another time by 2. Okay, so if we multiply it by 1, nothing happens to the vector. If we multiply it by 2, it's like taking it and going twice as much. Okay, it's like walking in this direction and then continuing to walk in the same direction again. And each time we added the other vector. Once the first time we didn't multiply it, we multiplied it by 0, so it was like a point, like not going at all. The second time we multiplied it by 1, so it's going in this length, and the second time we multiplied it by 2, which was like walking and then continuing to walk like twice as much as we did. We walked in total twice. Okay, so what do you think will happen? We will have, and we each time we make a parallelogram, and because we walk along the blue one and we walk along from that point, we walk along the red one. We're like copying the red one to here. So one time the red one is twice as big, one time it's the same size, one time it's no size at all. So what will happen? We will get all sorts of parallelograms. Okay, they will all have this orientation. One time it would be like this, one time it would be like this, one time it would be flat. Okay, so let's see it happening. So 0 and 0, it's like multiplying this by 0 and multiplying this by 0, so it's all remaining in the origin. So nothing happened. I can't draw it, but it's this point. It's the origin point. X equals 0 and y equals 0. Okay, so it's like pointing, drawing a point here. Okay, let's draw a point, but we will not see it. Okay, so we can't draw an arrow, it's just a point. And if we have 0 and 1, so it's 0 in this direction and 1 in this direction. So it's basically it's the red vector. We already drew it. If we already drew it. If we want, we can draw it in a new color, for example purple, but I don't want to mess up the painting. So it would be like going over the red vector, this time with purple. Okay, so Maybe we should. I'm sorry it's on the same drawing, but okay, so it's this one. Now 0 and 2, so it's 0 to the right or left and 2 upwards. So it's 2 in the positive y direction from 0, 1, 2. Okay, so it's this one because we are not adding the blue vector at all. Remember, it was 0 times the blue vector and 2 times the red vector. So this is what we get. Now 2 and 1. So we are going, it's basically the blue vector because it's 1 times the blue vector and 0 times the red vector. So it's 2 and 1. This is the blue vector. I'm just drawing over it with purple. Okay? And 2 and 2. So it's 2 to here and 2 to here. Okay, this is what we talked about, the blue plus the red. Okay, so it gives a parallelogram, and this is the diagonal. Each time it's a diagonal of a parallelogram, but sometimes the parallelogram is squished like this or like this. Okay, now 2 and 3, so 2 to the x and 3 in the y, 2 in the x direction, positive x direction, and 3 in the positive y direction. So it's 2 and 3. 3 would be here. Okay, this is what happens if we take 1 times the blue vector and 2 times the red vector. Okay, 1 times the blue vector and 2 times the red vector. Let's see about the 3 last cases. 4 and 2, so we are going 4, 1, 2, 1, 2, 3, 4, and 2 upwards, 1, 2. So they meet here. As you see, this continues the blue vector, just making it another time. So it's the case of 2 times the blue vector and nothing of the red vector. Okay, so we are just continuing the blue vector. Okay. And another case, 4 and 3. 4 to the right and 3 upwards. Okay, this happens when we take 2 times the blue one and 1 times the red one. Okay, the red one that was here, just adding it to the 2 times the blue one. Okay, 2 times the blue one plus 1 times the red one. And lastly, 4 and 4, which is 4 to the side and 4 to this upwards, we get to be here. It's like continuing the 2 by 2 vector that we had before. If you remember, we had this vector which was 2 by 2. So we are just continuing it more. Just putting 2 of these one after the other, and we have 4 by 4. Okay, so this is a 4 by 4 vector, and these are all the arrows or vectors that we were asked to draw in this question. Now, you see that we get to every point. If we multiply by every possible number, we get basically to every point. We didn't use numbers with the decimal points, we only used whole numbers, integers, but we got to, basically we will get to every point, and this is what it tries to show us, the author. It tries to show that we get a linear combination of two different vectors in the plane covers the whole plane. Okay, so that's it. Thank you.